Okay, now we have this function y is equal to 2x minus 5 x minus 1 into x minus 1. We need to find the standard form of this function, so let's write down this function y is equal to 2x minus 5 into x minus 1. To find the standard form, we simply multiply the binomials. That will become 2x square minus 2x minus 5x and plus 5. We simplify this further by adding or subtracting the like terms. Here in this case we add minus 2 and minus 5. It will become minus 7x plus 5. This is the standard form of the given quadratic function. Now what we do, we will find the vertex form of the function. For vertex form we need to actually use the standard form, that is 2x square minus 7x plus 5. So let's write it down. So the equation is y is equal to 2x square minus 7x plus 5. For this, let's take common 2 from first two terms. That will make it x square minus 7 by 2x plus 5. Now we need to make it a whole square because the vertex form of the quadratic function is like this: y is equal to a into x minus h whole square minus k. We need to convert this equation into this form. So let first we have taken 2 common from the first two terms. Now we need to make this x square minus 7 by 2x a whole square, complete square. So to complete this square, what I'm gonna do is I'm gonna minus 7 by 2x, I'm gonna add 7 by 4 whole square, and I'm gonna subtract 7 by 4 whole square at the same time. Let me explain why I did that. As you can see, this is x square. I can write it in x square. I'm trying to make this formula as a square minus 2ab plus b square. So let's write it down further as y is equal to 2 into, this is a square minus 2 into a into b. As you can see, 2 will be multiplied by 7 by 4, and 2 and 4 will 2 will cancel out 4, and the result will be 7 by 2x. So and plus 7 by 4 whole square, and that 7 by 4 whole square, bracket close, and plus 5. Now as the this is a square minus 2ab plus b square, we complete this square by writing it as 2 into, let's write the greater bracket, x minus 7 by 4 whole square. This completes the square. What are the terms that complete the square? These are the terms that complete the square. Okay, now what we have left is minus 7 by 4 whole square, bracket close, plus 5. Now we just simplify and multiply 2 inside. That will make it 2 into x minus 7 by 4 whole square minus 2 into 7 by 4 whole square plus 5. We can see that this will become 2 into x minus 7 by 4 whole square minus 2 into, we take the squares of 7 and 4. The square of 7 is, or 7 squared is 49, and 4 squared is 16, plus 5. Now we just need to simplify it further. Y is equal to 2x is just simple simplification, and minus 2, this 2 will be cancelled out with 16. uh, this will become 49 by 8 plus 5. Now we need to add this plus 5 and minus 49 by 8 to get the standard, to get to the standard form. Okay, y is equal to 2 into x minus 7 by x whole square minus, now when we add this, the LCM is 8. So 8 ones are 8, and 1 multiply 49 will be 49. As we have taken this minus common, so minus will be here, and 8 will be multiplied with 5. This will become 40. So this will simplify as y is equal to 2 into x minus 7 by 4 whole square minus 49 minus 40 will become 9 divided by 8. This is the required standard form. Oops. Yeah, this is the required standard form. This, as I have shown you earlier, told you earlier, that this will look like this. Y is equal to a into x minus h whole square minus k. Here a is 2, h is 7 by 4, and k is 9 by 8. So this is the required vertex form of the given function. Now let's head to the third step, or third requirement that we need to find for this question. The third requirement is we need to find the x-intercept. Uh, for this we can do it in two ways, because let me show you how. As you can see that we have this function. This function is already factorized. Okay, 2x minus 5 into x minus 1. We can use this function, or we can use this function. If we use this function, we're gonna have to do the reverse process by factorizing it again. So I'm gonna use this function. It will it will make it efficient and save time. Otherwise we can use this function too, but we need to factorize it, or use the completing square method, or the quadratic formula method, whatever that you find easy. Now let's use the factorized form, that is 2x minus 5 into x minus 1, to find the x-intercepts. All right, let's find x-intercepts of the given function. The given function is, the given function is y is equal to 2x minus 5 into x minus 1. So we're going to use that form. Y is equal to 2x minus 5 into x minus 1. So to find x-intercept, what we're gonna do, we're gonna put y is equal to 0 and solve for x. So when we will put y is equal to 0, that will become 2x minus 5, x minus 1 is equal to 0. Okay, as the two binomials are being multiplied and their product is equal to 0, so we can conclude that either 2x minus 5 is equal to 0, or x minus 1 is equal to 0. So we're gonna write 2x minus 5 is equal to 0, or x minus 1 is equal to 0. From here we will solve for x. 2x is equal to 5, or x is equal to 1, and from here x will become 5 by 2, and x is equal to 1. So we have these two x intercepts. We have to write in the intercept form, that is the point form or coordinate form. 5 by 2 and 0. What this is 0 represent, this 0 means that y is 0. Obviously the x-intercept are the points where the graph crosses x-axis, and wherever the graph crosses x-axis, y will be 0. So 5 by 2, 0, and another x-intercept is 1 and 0. Now let's move to finding the y-intercept of the quadratic function. Now we can also use this ordered pair. Okay, let's use this ordered pair, or we can also use the standard form. Whatever you prefer, the procedure is same. Let's use this ordered pair to find y-intercept. The ordered pair is y is equal to 2x minus 5 into x minus 1. Now, to find y-intercept, we're gonna put x is equal to 0. Y-intercept is the point that the graph crosses y-axis. So wherever the graph crosses y-axis, that point will have x coordinate 0. So putting x is equal to 0, we have y is equal to 2 into 0 minus 5, 0 minus 5. So putting x is equal to 0, we have y is equal to 2 into 0 minus 5 and 0 minus 1. This will simplify to 0 minus 5 and 0 minus 1, or this will become minus 5 into minus 1 and 5. So we're going to write it in the intercept form, that is 0 and 5. This is the y-intercept. What this 0 represents? This 0 represents that x coordinate is 0, and at the point where the graph is crossing x-axis. Now let's head forward, finding axis of symmetry. To find axis of symmetry, we need the standard form. The standard form of the function, if you can remember, is y is equal to 2x square minus 7x plus 5. So here a is equal to 2, b is equal to minus 7, and c is equal to 5. The axis of equation of axis of symmetry, the formula for equation of axis of symmetry is x is equal to minus b over 2a. Okay, now we substitute the values. Minus into minus 7 divided by 2 into what is the value of a? The value of a is 2. So okay, simplifying this will become x is equal to 7 7 divided by 4. So this is the axis of symmetry. The axis of symmetry for a parabola is the line about which the parabola is symmetrical if we flip it over